So here's another example, and so it contains an exponential expression on the left-hand side, e to the 2x. So the variable is in the exponent, right? Now, if I'm not careful enough and I start, okay, the teacher said just take logs on both sides, it's easier. If you do that, you're going to get stuck because you're going to get log of a sum of two things. And there are no rules to simplify the log of a sum. You can break up log of a product into the sum of two logs, okay? But the log of a sum, okay, is not going to be the sum of the logs, okay? It's going to be, it would work if those were multiplied. So that's no good, okay? Log of a sum, that's usually bad news, okay? You're going to get stuck. So this is why I was recommending in the previous video, if you've got like a constant here or even other constants like this one, you want to get rid of those, okay? Before you start doing anything. So we're going to send like all the stuff we don't want on the other side. So 12 minus 5 is 7, and ultimately I want to get rid of the 4, so I'm going to divide by 4. Okay, and now it's set up so that I just have my power of x on one side. Okay, and then I can start using like whatever solution I want, whatever type of solution I want. I could take logs here on both sides, or maybe convert this to a logarithmic equation. So those are possible solutions. So maybe I'll show you solution 1. Solution 1, you can convert this to a logarithmic equation. You could say 2x is the power, right? So it's power is a log, 2h I raise e, in order to get 7/4. Okay, and log in base e, it has a special name, right? This is ln of 7/4. The advantage here is that there's also an ln button or a calculator, so we wouldn't have to use the change of base formula to calculate the log in base e. And finally, we solve for x like that. Okay. Well, by the way, this answer, it could be written differently using properties of logs. The 1/2, I could send it as a power inside. The advantage of having a power of 1/2, 1/2 is when it's in the exponent, it comes down to taking the square root, and 4 is actually a perfect square. So this can be simplified to root of 7, ln of root of 7/2. Okay, so this is solution number 1. Solution number 2, okay, is to, like I said, not think too much. This is the one if you're not aware of what's going on, this will still work. You take, okay, you've got your equation written in the form b to the x equals a constant. Just take logs on both sides. You can take the log in any base, ideally base 10 or base e, because those buttons will show up on your calculator if you eventually need to calculate something. But since e is the base here, I'm tempted to use log in base e. So ln on both sides. Okay, and here I've got something like ln log in base e of e to the something. Well, that's going to give me that something, right? Because log in base e and e to the and the exponential function with base e are inverse function of one another. So this is just 2x, and that's going to be equal to ln of 7/4. And once again, we get x is 1/2 ln of 7/4, and then I could do the simplifications I did on the other side here and get ln of root 7/2. So I get the same answer either way. Right, so I'm going to get that as well. Okay, and I could calculate this using my calculator and verify that it actually works when I replace it into the equation.